I know. I haven't had this really I haven't had
Added new number 8.
All right, here we go. 5, please. 5, please. I'm out. 5, please. All right, thank you. Any question on the homework?
No.
Not on the homework.
It was 16.
Let's take a look. I need you guys to be quiet. Let's take a look at number 16. 6 and 5, 6 plus 4 and 7 ninths. Okay, the process is we change each one to an improper fraction. 6 times 6
36.
plus 5
35.
all over 6 plus 9 times 4
36.
plus 7, 36 and 7
40.
all over 9. Common denominator, 6 and 9.
36.
8, 36 would work, just larger. 18 is the least common denominator. All right, 18, that means I'm going to multiply this one times. You get to 18
3.
times 3. 3 times 41 is 123, large number. 9 times what is 18?
2.
Double 43 is?
What?
Double 43?
46. 86.
All over 18. All right, big numbers, 123 and 86. If we add those together, it looks like we get 209. So we get 209 over 18. Let's see, does 3 go into this? 2 plus 9 is 11. Nope. So 2 over 9 over 18 would be as an improper fraction. You need to write as a mixed number. We're going to count by 18. No, I can't do that other than 36. So I need to do some long division. So let's see, 209 divided by 18. That's close to 20. That would be 10 times. Way too many. It's either 9 or 8 or 7. I don't know. I'll guess 8. That goes 1 time. 18 goes into 20 1 time. 18 subtract. That gives me a 2. 29. 18 goes into 29 1 time. So it's 11 times. Okay. So 11 times. So we know the mixed number is 11. 11 times 18. This is a lot of work. 8, 8, 0, 1, 1. We get 198. We subtract that from 209. 209 minus 198. 1, 9 from 10 is a 1, and we get 11. So 11 18. So that was a lot of work. Agreed. Yes.
Can I show you a trick?
What's the trick?
So if you take the 2 whole numbers and you add them and subtract them, whichever one.
What do you mean the 2 whole? I mean these 2.
Yeah, those 2.
Yeah.
And if you add them or subtract them, that will give you a round of what area you're in.
Well, that's true.
That's a smart trick.
See what she's saying? She's saying you want to find out what this whole number is. In other words, 6 plus 4 is 10. It's going to be somewhere close to 10. It's either going to be 11 or maybe it's 9, depending on your subtract. That'll work. Estimations are good. All right. It is Friday, so all I do is collect the homework on Friday.
I thought you did that homework as well.
Well, yes.
Robert is on page
All right.
218. And
Everyone else, let's look at the messiness right here. I'll erase that. Just remember the procedure, not next week, but the following week. Quiet, please. The procedure for semester finals will be on that Monday, full day, not half day. Full day on that Monday. You'll take your English final. You'll come back the next day. That's for 6th and 7th period. So 6th and 7th period will be your semester final in English. Come back for Tuesday through Thursday, 2 finals a day, half day. Student advisement 30 minutes, final 1. Student advisement 30 minutes, final 2, go home. Okay. If you've done all your semester finals on Thursday, then you do not need to come to school on that Friday. If you've missed any of your finals, we will make sure we remind you, you got to come to school on that Friday. If you missed 1 final, you take 1 final, you go home. We're not going to keep you to 12 o'clock. If you missed 3 finals, man, oh God have mercy on your soul, because you're taking 3 finals on that Friday, right? So obviously, make sure you communicate us if there's something strange going on. Hey, I was sick. We're not going to make someone take all 7 finals on that Friday. If you're really sick for that many days, don't panic on something like that. But yeah, typically what happens if you're absent for one day, you're going to take those 2 finals on that Friday. What's up? Yes. No, you got to come in like everybody else. Yes.
Okay. If we do have to come on Friday, that's Friday out. Do we have 4 uniforms?
Absolutely. Not. Yes.
For my homework, I didn't do some of the fractions. I was gonna come back and I forgot.
Okay. All right, here's your homework. Coming down, please. Turns out that we have done the hardest stuff of the chapter. It's now behind us. The hardest stuff of the chapter is adding, subtracting when you don't have common denominators. The rest of the chapter, multiplication, division, and applications of that stuff, is actually easier. Turns out the multiplication, division with fractions is easier than adding, subtracting. Go figure. Yes. Something that's reduction. Yes.
You do
With
No.
when you're multiplying whole numbers against fractions, don't you make the whole numbers fractions by putting the whole number above a 1
That's correct.
as the denominator?
As a denominator.
Yeah.
All right, 1 through 16, all, like I said, multiplication is actually easier. You will not be spending forever doing this homework because it's pretty quickly done. All right, here we go. Multiplying fractions. Think about this. 4 plus 4 plus 4 is 12. A long time ago, mathematicians said we are lazy. I mean, we are efficient, and there is an easier, simpler way, not of doing the math, but of writing the math. Instead of writing 4 3 times, right, we use this simplifying method called multiplication. This method right here it doesn't change this process of addition. All it does is it writes it more efficiently. Instead of writing 4 3 times, we say that 4 is written 3 times in the following manner: 3 times 4. By the way, we memorized this answer. That's why we spent time in 2nd, 3rd, 4th grade memorizing our multiplication table. Okay? So multiplication is the way of showing repeated addition more efficiently. You don't want to write 10 times 12 as 10 plus 10 plus 10 plus 10 plus 10 plus 10 plus 10. I've already lost count. 12 times. It's much more easier to say 10 times 12 and then memorize that the answer is 120. Okay, so it's not that we are lazy, it's just it's more efficient. All right, visually, this is how we represent this. Visually, we represent multiplication, right, as a group of items. In this case, I have 3 rows of 4. This is visually how you identify 3 times 4. Okay, agreed. Now pay attention. All right, so multiplication, we've done it before. No, this is not a class on multiplying integers. This is a class on multiplying fractions. So when we multiply fractions, it doesn't change, right? We simply have fractions involved. All right, well, let's see how this works. If 3 times 4 could be written as 4 plus 4 plus 4, 4 written 3 times, well, then the same thing must be true. If we write 4 3 times, and that's what this equals, we should be able to write 1 4 3 times, right? Well, I write 1 4 3 times, therefore the answer is?
3 4.
Okay. Seems to me there must be an easier way. If there was an easier way, we memorize the answer here. Seems to me there should be an easier way. What's the easier way? All we need to do is take this number 3 and multiply it by
1.
All we got to do is multiply that by 1 and we get to the answer. That is what we will be doing. Box 1, please write this down. When you have a whole number multiplied by a fraction. So you're multiplying a whole number times a fraction, 3 steps. Step number 1, you multiply the whole number by the numerator. Step number 2, you rewrite the denominator. Technically, you're done at that point, but since it's fractions, we always have this last step, which is reduce, write as a mixed number. Yes?
I just figured out that you don't have to make the whole number a fraction in these problems. You can just multiply.
That was literally what I just said.
Oh.
Yes? Hurry up. So, as Ace said, because he wasn't paying attention, and what I just said was, well, all you do is you take the whole number, you multiply it by the numerator, rewrite the denominator, and then since it's fractions, we always have that last step of reduce / write as a mixed number if necessary. Step 1, 2, 3. Like I said, multiplication ends up being way easier than addition. Yeah, it's a paradox because typically with whole numbers, multiplication and division is more challenging than adding and subtracting. All right, we got it all copied down?
No.
Okay, so let's do some. Well, the step 1 says you multiply the whole number times the numerator. The numerator is 1. 5 times 1 is. So step 1, you write 5. Step 2 says rewrite the denominator. The denominator is 2. So 5 over, and then we reduce. Can this be reduced?
Yeah.
Reduced?
No.
Yes.
Well, what goes into 5 and 2?
Nothing.
It's one. No.
It's fully reduced. Okay, but it does say step 3, it says write as a mixed number. 2 goes into 5 twice with how many left over? So 2 and 1/2. Okay. Question or are you stretching? All right, one more time. Step number 1 says multiply the whole number times the numerator. 3 times 3 is
12.
Okay. We rewrite the denominator. Step 2, 7. Can this be reduced? No, so we change it to a mixed. You won't always have to change it to a mixed number, but in this case you do. 7 goes into 9 with how many left over? So 1 and 2 sevenths. Okay? All right. Now notice all I did was flip the order around. Before it was a whole number times a fraction. Now it's a fraction times a whole number. The process doesn't change. Remember, multiplication is commutative. If we really wanted to move it to the other side, we could. Not necessary. We just multiply the numerator times the whole number. 2 times 6. We write 12. The denominator is, can this one be reduced? Yes, by 3. So we divide top and bottom by 3. 12 divided by 3 is? 9 divided by 3 is?
3.
So we get 4/3. Oh, I've got to write as a mixed number. 3 goes into 4 with how many left over? So 1 and 1/3. Stop me if you're lost. Well, I got to do the whole class. All right, let's do one. Here we go, box 2. Whole number times a fraction. Whole number times the numerator. 3 times 2 is step 1. Step 2 over the denominator. Denominator is 9. Can we reduce this? So we're dividing by 3. Top and bottom by 3. 6 divided by 3 is? And everyone already was yelling out the answer. It was 2/3. Everybody okay? All right. Last one. Let's see. Fraction times a whole number. Same process. Numerator times whole number. 1 times 4 is all over the denominator, which is, can we reduce that? Yep. Divide by. Okay. Top and bottom by 2 gives us 2 over 1. What is that?
Just 2.
Yeah, because 2 divided by 1 is 2. So plain old 2. All right. 5 times 3 is all over. How many times is 8 going to 15? With how many left over?
7.
So 1 and 7/8. Stop me if I'm going too fast.
You're going too slow.
I'm going too slow? Okay. All right, do box 5 all by yourself. I'm going to show you a couple other things, but
Yeah, that's all.
218.
How do we
You're saying
do the
two.
back?
what?
How do we do the back side?
The backside. Well, I'm gonna teach it to you.
Can you teach it to us now? Because we all know how to do it.
You, I got box 5 done.
Yeah.
No.
The bottom one's 412. And the top
The
one.
bottom one is not 412. Oh, now you're thinking.
And the top one is going to be.
Bottom one is 1/3.
Gavin, the top one's gonna be.
That's gonna be 8/5, but then we have to do the thingy. So then it'll be.
1 3/5.
Yeah.
Thingy.
Oh, I'm glad that you're specific on telling me what the process is. So we will now call it the thingy. All right. The last one.
Do the mixed number.
So then what you have to do is you do 4 times 1, and then you have to reduce to 1 and then we do 30.
Well, you still haven't told me what the answer was.
Oh, it's 1/3. Oh,
Well-
that's 1 3/5.
Yeah, but the second one.
Yeah, 1/3.
Yeah, but before that,
Oh, it was 4/12.
and then that turns into
1/3.
because
You have to reduce.
5
We needed to do 4.
by 4. Okay, now I'll find. All right, so you're a big kid now because you just can multiply fractions. All right, write this down, please. Box 6
already there.
tonight. Oh, tonight for homework. I usually get some students say, I didn't understand the instructions. It said simplify the expression. So what does that mean? Simplify means, well, when you write something in what's called simplest forms. Now, most English language arts teachers would hate this definition because I'm using the word simple to define simplify. But this is how math people do it. It doesn't mean solve it. Solve it is an entirely different procedure.
You can say
Simplify, what I typically tell students, simplify means do the math. Solve is when you have an equation with a letter, a variable, and you find out what that letter's value is. That's solve. So no, you're not going to be solving these. You are going to be simplifying. Expression is just a fancy way of saying you got 2 or more things to add, subtract, multiply, or divide. An expression is a combination of letters and numbers and operation symbols. Okay? And I say letters, I mean variables. No, we're not going to see variables today. These are all going to be numerical expressions. All right, so we're moving on. Did you notice, and this was a couple people already mentioned this, right? Is that when we did this particular one, we did 1 times 4, we got 4, over 2, we reduced, we got to this answer. Some of you have already noticed that between the start and the finish, right, that the following happened. Is that if I had written 4 as 4 over 1, I would have gotten the same answer. This is how we get to the next step, which is how do you truly multiply a fraction times a fraction. And we notice this. If I take this whole number and I write it as a fraction, 4 over 1, 1 times 4 is still 4, but what's 2 times 1? We get the same answer, which is why the more general rule for multiplying fraction is, anybody know? Well, how do we multiply fractions?
Across.
That's where we get this more general form of the rule for multiplying fractions, multiply across. Most math books won't say literally, hey, the rule is multiply across. They will say multiply numerators with numerators, denominators with denominators. Okay? But yes, most math teachers, myself included, will tell you multiply straight across. This is not the rule for division. This is only the rule for multiplication. Division gets its own special rule. But for multiplication, yes, the rule is we multiply straight across. Numerators with numerators, denominators with denominators.
I have a question.
The other 2 steps stay the same. Okay? So, box 7, write this down. This is the more general rule for multiplying with fractions. Now, be careful. When I say fractions, I'm not including mixed numbers. This is specifically for proper and improper fractions. Step number 1, multiply the numerator with the numerator. That means the numerator of fraction 1 times the numerator of fraction 2. Step number 2, we multiply the denominator of fraction 1 times the denominator of fraction 2. Step 3 stays the same, reduce, change to a mixed number if necessary. Technically, it's the same rule as multiplying a whole number times a fraction. If you write the whole number as a fraction, well, then this rule applies to it as well. But I do want to point out that you're not required to write a whole number as a fraction, right? You can simply multiply the whole number times the numerator. But if you'd like to, well, then now there's one rule for all fractions except for mixed numbers. Mixed numbers gets their own special rule for multiplication and division because they're special.
What is that?
Change to improper fraction, multiply. This is Monday's class. Or maybe Monday's division, and then we do mixed numbers. I forget which. One of the two. Malachi, you didn't write down anything. Come on, let's go.
That's the entire class.
Oh, he's just kind of just sitting. Now he's right. Yes, Lily.
How long are the Friday classes?
Say one more time.
Like, how long are the Friday classes?
37 minutes.
They're too long.
We get out at 2 instead of 3:30.
I have a
Get
question.
out at 12.
I have a question. That like extra hour, you let us sleep.
If we
in
got
an
out
hour.
at 12, that would mean our teacher meeting would last 4 hours. No, thank you. Too long.
I have a question.
Oh, it's so
Just to talk about the.
If I had made the decision, we'd have the teacher meeting on like Tuesdays or something.
You guys should have it,
No,
like,
they decided to have it on Fridays.
You guys should have it like on a Zoom meeting at home.
Yes, agreed.
And Mount Springs.
Well, correct.
Tell your teacher.
All right.
38. Can we change it so instead of getting out an hour early, we come in an hour early so we can sleep in?
I'd be okay with that because for me, I don't mind coming in early and doing a teacher meeting. What I mind is on a Friday staying late to have a teacher meeting. All right, here we go. But that's my own cross to bear. All right, so here's how this process works. Step number 1 says numerators with numerators. 1 times 2 is 2. So straight across 2. Step 2 says denominators with denominators. 2 times 3 is 6. Okay. Step 3 says reduce. What goes into 2 and 6?
2.
So we divide top and bottom by 2 and we get.
1/3.
Now, no one's made the comment that when you look at homework, none of these are other than questions 1 through say 6. None of these are nice, friendly, small numbers like I'm giving you here. Well, we're not going to spend much time with the much larger numbers. I want to do as many problems as we can, but yes, the process doesn't change. Homework is slightly more challenging because the numbers are larger. All right, let's do one. Box 8, listen please. Box 8. Step number 1 says numerator times numerator. Numerator times numerator. 4 times 3 is 12. You're right, 12. 7 times 5, that's step 2. Denominator times denominator. 7 times 5 is?
35.
Does anything go into 12 and 35? Nothing? Well, then that's your answer. Okay. That was box number 8. Questions? All right. Box number 9. One more time. Step number 1, numerator times numerator. 2 times 2 is? 4. Step number 2, denominator times denominator. 5 times 3 is?
15.
Step number 3, reduce. Does anything go into 4 and 15? So that's your answer. Do you agree that multiplication is easier than addition?
No.
Yes.
Most people would say yes.
So much easier.
All right. Now for some math magic, right?
Woo!
All right. Now, this is generally for 7th grade. Some of you might have seen this before. Some of you have never seen this before. This is not a required step. Are you listening?
Yeah.
This is not a required, so why would I do it? Because it'll make it easier. Gavin, not a good time to be walking around. What? All right, well, remember, don't get up without asking permission. All right, so everyone look at the board. Notice I have this box 10. I have the same problem written twice, right? All right, I'm going to do the first one the way I just taught you. Watch me. Step 1, numerators. 5 times 3 is 15. Step 2, denominators. 9 times 4 is 36. So I get 15 over 36. Now I reduce. Step number 3. What goes into 15 and 36? 3. So I'm going to divide top and bottom by 3. That gives me 5 5/12. There is nothing wrong with that technique. It will work every time. It turns out that there's a slightly easier way of doing this. When these numbers get really big, this technique is way easier. When the numbers are small, this technique is not that much easier. But when the numbers, like tonight for homework, questions number
16.
say 14,
No, do 9.
12,
Do 9.
these ones right here, this method, please stop. This method is way easier. Watch me. This method has a name. It's called cross reduction, not cross multiply, cross reduction. We're going to do this reduction right here, the divide by 3 as our first step. What we're going to do is this. If everybody looking, I'm going to look at my two fractions. I'm going to look at these two numbers. E-learners, I'm circling 5 and 4. And we're going to look at these two numbers, 9 and 3. Do you see the cross?
Yes.
Right? I'm going to look at those two numbers separately, meaning each cross one at a time. And I'm going to ask myself, is there anything that goes into either cross? Is there any number that goes into 5 and 4 other than 1?
No.
Any number that goes into 5 and 4 other than 1? Any number that goes into?
No.
No. Now I look at the second cross, the 9 and 3. Is there any number that goes into 9 and 3?
Yes. 3.
The number is 3. So here's cross reduction in action. I'm going to do this reduction right here. Step 1. 3 goes into 3 how many times?
1.
3 goes into 9 how many times?
3.
So I'm going to cross reduce. In other words, I'm going to change those numbers. 3 now becomes a 1 because you said 3 goes in at 1 time. 3 goes into 9 3 times. Now notice I did mine in color. What typically happens with this process is it gets really messy, especially for kids with messy handwriting. Sometimes you can't see the numbers. Mine are easy because I did mine in red. This is no longer a 3, it's a 1. This is no longer a 9, it's 3. Watch what happens. What's 5 times 1?
5.
What's 3 times 4?
12.
There's your answer.
That's because it's already
Right. So all we did was change the order of where we did reduction. Now, why would this be a good thing to do? Because when these numbers are really large, technique number 1 is we're multiplying, 25 times 74. Really large numbers. Okay, it'll still work. And now you're reducing by a lot. If you reduce as your first step, you're multiplying with much smaller numbers. Let's see that again. All right, this is box number 11. All right, we look at the crosses one at a time. Does anything go into 1 and 13? Other than 1? No. Does anything go into 5 and 10? 5. 5 goes into 5 how many times? So we cross through the 5 and we write a 1. 5 goes into 10 how many times? So we cross out the 10 and we write a 2. Now look, I'm not multiplying 5 times 13. I'm multiplying 1 times 13. Life is easier.
It's 2.
1 times 2 is?
2.
And 1 times 13 is?
13.
And you're done in that easy of a step. Cross reduction is pretty slick. When the numbers are really small, it doesn't necessarily speed things up. But when the numbers are larger, like here, I got to multiply 10 times 12 on the second one. Yuck, 120. Or I do cross reduction. Does anything go into 3 and 12?
Yeah.
What?
3.
3 goes into 3 how many times? So I cross out the, well, I did a different order. Does anything go into 5 and 10?
2. 5.
Okay, 5 goes into 10 how many times?
2.
I cross out the 10 and I write a 2. 5 goes into 5 how many times?
1.
So I cross out the 5, I write a 1. All right, now we're back to 3 and 12. What goes into 3 and 12?
3.
3 goes into 3 how many times?
1.
3 goes into 12 how many times? Now notice, mine's nice and neat because I did in PowerPoint and my numbers are red. Yours will all be black because you're using a pencil. If you are really sloppy, right, sometimes you can't even read what numbers you're writing. But watch the magic, what happens. I reduce first instead of last. What's 1 times 1?
1 times 1 is 1.
What's 2 times 4? That's crazy easier than multiplying 3 times 5, 15 over 120. You're reducing 15 over 120, divide by 5, and continue on. Okay? This is called cross reduction. It is universally accepted as the easiest way of multiplying fractions. In fact, you get to Algebra 1, no one even questions whether you should reduce. On your homework, I'm going to take a look at number 13. Number 13 says the following: 42 over 55 times 30 over 14. Ugly numbers. Look how ugly those numbers. We've got to multiply 42 times 30 if we don't cross reduce. If we cross reduce now, watch how easier it is. Red pen. What goes into 42 and 14? 7 goes into 42 how many times? 7 goes into 14 how many times? What goes into 30 and 55? 5 goes into 30 how many times? 5 goes into 55 how many times?
11.
Watch how much easier that is. 6 times 6?
36. 22.
And you're done. Oh, wait, we can still reduce, right? What goes into 36 and 22?
2.
So we get 18 over 11, change it mixed up. I'm just saying that you can see how easy cross reduction is here. Yes?
Do we have to change?
You have to change all your answers to mixed numbers if they're in proper fractions, yes. Okay, so I would highly encourage you guys to do cross reduction and get good at it, because it will make your life easier when the numbers are larger. Tonight for homework, over the weekend, questions, I don't know, call it 10 through the rest. They're pretty large. What's up, Caden?
So this mean that does this mean that after you do cross reduction that you don't need to reduce because it'll be the small?
It will be, but you got to fully cross reduce. That one that I just right there, I could have reduced one more time and I didn't. But if you fully cross reduce, it will be. Okay, the second one here is kind of showing you the power of this. First one, really small numbers, you could do it either way. It's the same number of steps. Hey, watch what happens when I cross reduce. What goes into 2 and 2?
2.
Okay, 2 goes into 2 how many times? 1. All right. That becomes a 1, that becomes a 1. What goes into 3 and 3?
3.
All right, well, 1 and 1. 1 times 1 is?
1.
Over, which is?
1.
All right, now I'm not going to claim that I sped things up because 2 times 3 is 6. 3 comes, you get 6 over 6. The power of cross reduction isn't in this one. It's in the second one. Do you want to multiply 14 times 27?
Yes.
No. Sometimes you might have to. If you can't cross reduce, then you're stuck multiplying 14 times 27. However, I do know what goes into 14 and 28. Okay, 7 goes into 14.
Well, 14 actually, yes.
Okay, 14 goes into 14 one time, he says, instead of 7.
And then 14 goes into 28 twice.
14 goes into 28 twice. What goes into 9 and 27?
9.
3 or 9, right? 9 goes into 9. 9 goes into 27.
3.
Now look at the numbers in red that you're multiplying. Isn't life a little bit easier? I'm not multiplying 14 times 27. I'm not multiplying 9 times 28. I'm multiplying 1 times 3. I'm multiplying 1 times 2. Crazy easy. Yes, you have to change that to a mixed number. That's 1 and 1 and 1/2. Who's lost on cross reduction?
I've been using the cross reduction like 9 and 10. It's like way easier because I got
Way easier.
1 times 2 and 1 times 3.
Agreed. Way easier.
Can 825 out of 1,760 be reduced?
What were the numbers?
825 as the numerator and 1,760 as the.
Yeah, 5 goes into both.
How is it?
I would do some cross reduction first before I did that.
Okay.
Yes, because I'm out of time, and there is your homework. So get started on your homework. We got 3 minutes.
I think so, yeah.
3 Minuten, as they would say in Deutschland.
What's
I had to
Deutschland?
listen to
Germany. You do know that most countries don't use the American word for the name of the country? For instance, Germany is not called Germany if you're in Germany. If you're in France, they don't call themselves, I'm from France. If you're in France.
We're changing that. I'm going there and
If you live in Spain, you don't say, hey, the people of the United States, they say, no. If you're in Spain, they don't say, hey, look, there's someone from the United States. They say, well, how's it say United States? I used to know that. I don't know anymore. All right, e-learners, any questions?